Welcome back to Quantitative Aspects of Chemical Change, Lesson 9a, Calculations of Amounts Using Balanced Equations. In your textbooks you find this work on page 199 and to 201. First of all, I'm going to go through some basics. You'll find the example on page 199 where they describe the reaction between hydrogen and oxygen, and they use diagrams like we did in grade 8, 9 and 10. Now I expect you to be more advanced, so to balance the equation you need two atoms of oxygen on the right hand side to balance the two atoms of oxygen on the left hand side. And now if you do that, you see that you've got 4 atoms of hydrogen on the right hand side, so we need to write a 2 in front of the hydrogen to have 4 atoms of hydrogen on both sides. So the important thing is that you need a balanced equation. So that means that the number of atoms on the left hand side of each element equals the number of atoms on the right hand side of that element of the reaction equation. So from this we get the mole ratio. 2 moles of hydrogen will need 1 mole of oxygen to make 2 moles of H2O. Now to take it further, 1 mole of hydrogen will need 0.5 moles of oxygen to form 1 mole of water. The original ratio given by the balanced equation must be maintained. And that ratio is given by the coefficients of each of the reagents. You could go for 4 moles of hydrogen will need 2 moles of oxygen to give you 4 moles of water. Or you could go for half a mole of hydrogen. It will need a quarter mole oxygen, and it will give us a half a mole water. You can change these quantities anyhow. The mass ratio is more complicated to work with, so we're always going to change mass into moles. So the mass of 2 moles of hydrogen is 4 grams, and the mass of 1 mole of oxygen is 32 grams, and the mass of 2 moles of water is 36 grams. So if you double the mass, the oxygen must double, the water will double. Right? And then they also work with the number of molecules. So if you've got we know that Avogadro's number, so we know that 2 moles of hydrogen would be 2 times 6.022 exponent 23, so that would be 1.2044 times 10 to the 24, sorry. And that would require 6.022 times 10 to the 23 molecules of oxygen, and it will give us 1.20 times 10 to the 24 molecules of water. So these things are all linked up. Example 2 is on page 200 and it discusses the reaction between sulfur dioxide and oxygen. And if you balance the equation, you'll see that 2 moles of sulfur dioxide requires 1 mole of oxygen to give us 2 moles of sulfur trioxide. The mass ratio will give you 2 times 64. So that is 128 grams of sulfur dioxide needs 32 grams of oxygen, and it will give us 160 grams of sulfur trioxide. Just a note that I didn't make on the previous slide, if you add the mass of the reactants, it must equal the mass of the products. So in your textbook they describe the law of mass conservation. The total mass in a closed system remains constant, or matter is not created or destroyed during a chemical reaction. Example 3 is the example on page 200 that is in the grey block. It says calculate the amount of hydrogen formed when 2.5 moles zinc reacts completely with hydrogen chloride. So the important thing here is to be able to write the balanced equation. So hydrogen chloride reacts with zinc, and from pre-knowledge you need to know that zinc chloride will form and hydrogen will be released. To balance the equation, it seems like that you need a 2 there. So, to be able to answer question 3.1, you need the mole ratio. 2 moles of hydrogen chloride will react with 1 mole of zinc to form 1 mole of zinc chloride and 1 mole of hydrogen. And what is of interest in this question is the mole zinc to the mole hydrogen ratio. So if you have 2.5 moles zinc to start off with, it will form 2.5 mole of hydrogen. They wanted the amount, so they could have asked for the moles, but if they ask for the amount, then they want us to calculate mass. Mass is moles times molar mass. The moles is 2.5, the molar mass is 2. So there will be 5 grams of hydrogen forming. Oh, it seems like in the book's example, they want 2.5 moles of hydrogen. As the answer, 3.2, calculate the amount of HCl required to react. Now, HCl reacts in the ratio 2 moles of HCl to 1 mole of zinc. So, if we have to answer this question, 2.5 mole zinc will need 5 moles of HCl. If they asked you to calculate the mass, then you take the 5 moles and you multiply it by the molar mass. So I misinterpreted their equation. They're not with masses yet. So 5 times the molar mass. You have already used this 2 when you calculated the 5. So it's only the molar mass of HCl, which is 36.5. So 5 times 36.5 would be 182.5 grams. Thank you for watching the video. We have time for one more calculation here, so it's the example on page 201, where they actually inform you to calculate the mass of oxygen obtained when 14.7 grams of potassium chlorate decomposes completely to form potassium chloride. So I've already balanced the equation for you. 2 moles of potassium chlorate will give me 2 moles of potassium chloride and 3 moles of oxygen. So after writing the balanced equation, I always go to my mole ratio. Then I look at what they have given, 14.7 grams of potassium chlorate, and I write this as the given 14.7 grams of potassium chloride, and they want the mass of oxygen. So I'm going to write an M with a little question mark. Now, the easiest way is to use the mole ratio, not the mass ratio, the mole ratio. So this mass that they have given, this one, I need to convert to moles. Moles is mass over molar mass. So it is 14.7, and the molar mass of potassium chlorate is 122.5. 122.5. So the moles of potassium chlorate we have here is 0.12. Now, the mole ratio between potassium chlorate and oxygen is 2 to 3. So I need to divide this by 2 and multiply it by 3. Because if you divide by 2, you change the 2 to 1, and if you multiply the 1 by 3, you get 3. Maybe I've explained it in the wrong way, but this is the easiest way I can see how to do. Take this 2 and divide by the 2, and then multiply by that 3. So 0.12 times 3 divided by 2 will give you 0.18 mole. Now they've asked us to calculate the mass of oxygen. So to change the moles to mass, I need mass equals moles times molar mass. So it's 0.18 times, and it's 32 for oxygen, which gives us 5.76 grams. Thank you for watching the video. See you in the next one.